Okay, this lesson is going to be briefly on calculating the resistance in a series circuit. Alright, I'm going to talk about two of them, however, just real quick, a series and a parallel. Alright, so this first picture that I'm drawing is of a series circuit. Alright, the thing about the series circuit is, as you've seen in this picture, it makes it a series because it actually just goes around and around, like these dots show you. Okay, it just goes around and around and around. But in the event that, like, let's say something happens, like maybe this light bulb breaks, then the current can only flow, and it stops where the light bulb is. You see that little orange dot? It just flowed, and then it stopped where the light bulb broke. So now that means anything on this side won't receive any power. Okay? The other one is the parallel. This is a parallel circuit. And there's a big difference between the two. The big difference and advantage is this has multiple branches, all right? Remember, the series has only one path. Let me get something different. It has one path, all right? And this one has multiple paths. Oh my gosh, that's supposed to say multiple paths. Anyhow, multiple paths, all right? And when I mean it has multiple paths, that means electrons can flow, like you see here. Oh my gosh, what's going on? It's happening so fast. I'm sorry, that's just too quick. So anyhow, electrons can flow down each branch, and it can go around and around and around. And that's basically what's going on. Electrons are flowing down each branch, and that's why it has multiple paths. In the event that something happens, like let's say one of the resistors break, like that breaks, or both of those break, you still will be able to have power flow all the way around. It still won't stop. This light bulb right here will still be lit because power is still able to flow. That's the difference between a series and a parallel. Okay? So, again, that's a parallel. Let's move on. So here is, we're getting to go back to calculating resistance in a series circuit. So here is a series circuit with the resistors. So right now I want to calculate the total resistance in this series circuit. ER stands for equivalent resistance. So you would use a formula, and this is the formula that you would use. R total is equal to R1 plus R2 plus R3, and so on and so on. What does that basically mean? That means that you're adding everything in this entire series. All of those little dots you will add. So the 6 plus the 8 plus the 12 plus the 10. So let's do it real quick. And then you get 36. So the total resistance is 36 ohms. It's just that simple. Alright. Next. Here's another one. This is another series circuit. And I got all of my ohm resistors, or my resistors. By the way, this light bulb over here is also a resistor because, you'll see shortly that a resistor is any object or device that uses electricity. You might want to include this in your notes. If you don't have it, write it somewhere so you know. So anything like a fan, a radio, a TV, a phone, anything that uses electricity is a resistor. Okay? So how do you calculate this? You just add them, and your total resistance would be 56 ohms. Okay? Series resistors are super easy. Now, let's calculate the resistance in this next one. It's just going really slow. So let's calculate the resistance of a series circuit that has a 5 ohm, 6 ohm, 7 ohm, and a 15 ohm resistor. Let's do it. So now this is a word problem. The other ones have been pictures. Alright, so these are, the ones that I underlined are my resistors. So you're doing the exact same thing. 5 plus 6 plus 7 plus 15. Notice I did not actually write my ohms here, but the most important part is that you write them there at least. Your final answer should have ohms if you're talking about resistance. Alright? That's it.